Hi, so this video is going to be about the equation of a line. So we've been talking a little bit about lines in terms of slope. We talked about lines in terms of axes, intercepts. So we've talked a little bit about sort of attributes of lines. So now we're going to get to the equation of a line. So every straight line that you can draw on a set of axes has an equation attached to it. A line is made up of a series of points, an infinite number of points, in fact. And the equation of a line is a way of connecting the x and y coordinates on all of the points on that line. So think about all of those points as like a family. All of those points have some connection between their x and y coordinates that's the same for every single point. So as long as it's not horizontal or vertical, you can write the equation of a line in this form: y equals mx plus c, and that's called slope-intercept form, and we'll talk more about that a little bit later. But what you need to know is the x and the y are part of the equation. They're just there. That's the x coordinate and the y coordinate. M and c are constants, meaning that when you actually put that into practice, the m will be a number and the c will be a number. X and y will stay x and y. But this is the explanation of how the x and y coordinates are related to each other. Every single point on a line is going to be related in the same way, and that equation explains what the connection is. So if we look down here and we look at this line, y equals 2x. So that means every point on that line, the y coordinate is double the x coordinate. So for example, one of the points might be 1. If x is 1 and y is double that, then y is going to be 2. So that's a point that exists on that line. If y is 3, if x is 3, y is going to be double that, so the y coordinate would be 6. So that would be another point on the line. If x was -5, then double that. 2 times -5 gives me -10. So there's another point on the line. So all of these points are in this line family because every single pair of coordinates is connected in the way that the equation describes. The y coordinate of every point is equal to 2 times whatever the x coordinate was. So if we look down further here, it says state in words the meaning of the equation. Y equals 3x plus 7. So what that means is for every x coordinate, you would triple and add 7 to get the y coordinate. You can probably write that in a much clearer, straightforward, slightly different way even than what I've written it here. You could also sort of make the y coordinate the focus and say the y coordinate is 3 times the x coordinate plus 7. You can write that too. So that means that every point that exists on this line is in the family of, if you take x, multiply it by 3, add 7, you're going to get the y. So that's how all of that family of points is all connected together. So what we're going to do today is we're going to look at a table of values. We're going to look at a couple of them. And we're going to try to figure out what is the equation that connects these points. So you have to think of them as points this way. So the coordinates of that point would be 1, -3. And then we would have 2, -6, and so on. So read the table of values this way. So these are, what do we have here? 5 points, and they create 5 sets of coordinates. So if we were to graph them out, we could graph 1, -3, and we could graph 2, -6, and we could graph, that's not right at all. Let me start that over again. So we could graph that 1, -3, 2, -6, 3, -9, 4, -12. So you see that you have this straight line emerging from the coordinates of the given points. So that's the line. So we're trying to figure out what is the connection here that relates all of the points that exist on that line, the ones in the table of value and the ones that would sort of go from that. So these are kind of like little puzzles. You kind of got to think a little bit and sort of piece together, what could I have done to X to get Y? And so sometimes you might end up going through a few incorrect tries before you get to the right one. So let's imagine I take Y. What did I do to X to get from 1 to -3? Well, maybe I subtracted 4. 1 minus 4 equals -3. So 1 is my X coordinate, -3 is my Y coordinate. That works for the first point, but then if I go to the second point, 2 minus 4 gives me -2, which is not what I should get. I should be getting -6, but that's not what I get. So then I know that this one is not right. That will work for the first point, but it won't work for any of the other points. So I need the one connection, the one equation that's going to work for every single point. So try something else. So I can't get the correct answer by subtracting. What else could I do to 1 to get to -3? Well, maybe I multiplied it by 3 or -3. So maybe I had -3x. Okay, so let's test it. -3 times 1, that gives me -3. That's what I need. -3 times 2, that gives me -6. That's exactly what I need there. Try one more. -3 times 3 gives me -9, which is what I need for that. So this is the equation for that series of points. So that line's equation is y is equal to -3. So again, you might go through a couple of incorrect tries before you land on the one equation that's going to work for every point. Let's try another one. So this one, we have x1, y5. We've got 2 and 4, 3 and 3, 4 and 2, 5 and 1. So we need one equation that's going to match all of these points. So let's try something. So if y is 5, how did I get from 1 to 5? Well, maybe I added 4. Does that work here? 2 plus 4, nope, that doesn't give me 4. So that's not going to work. That one's out. Maybe I multiplied by 5. Maybe I had y equals 5x, because if I multiply 1 by 5, I get 5. But if I multiply 2 by 5, I don't get 4. So that's out. So maybe, what else could I do? Maybe I could multiply by 2 and then add 3. So I would have 2 times 1 plus 3, so 2 plus 3 equals 5. So it works for the first one. But then if I put in 2 times 2 plus 3, that gives me 4 plus 3, which gives me 7, which is not the 4 that I need. So that's not going to work. So sometimes you might be able to get it in one step where you only do one thing to the x, like these first two. Sometimes you might have to do 2 things to x, but that didn't work in this case either. So it requires us to look a little bit more closely at the numbers. So if I look at these numbers, maybe you've already noticed that each of them, if I put them together, will give me a total of 6, right? 5 plus 1, 6. 2 plus 4, 6. 3 plus 3, 6. 4 plus 2, 6. 5 plus 1, 6. So that gives us something we can work with. So instead of writing the equation with the y first, I can see that there is a connection here where if I do x plus y, I will get 6. So I could go ahead with that equation. That will work. It works for all of them. Or if you're really stuck on writing it in slope-intercept form with the y first, you could rearrange that equation. So if we want y by itself, we're going to subtract x from both sides, giving us y equals negative x plus 6. That would also work, and then it's in the same form, right? Y equals mx plus c, where we have a number in front of x and a number on its own. That would work too. So either of these, because they're essentially the same equation, just rearranged slightly, would work for this particular table of values. This is not an easy thing to do. It takes a lot of investigation, it takes some trial and error, it takes some thought. It's not easy. There's no one way that I can instruct you to just complete these questions. Like, do this and you will get the answer. These ones are more like little puzzles. They take a little bit more time and a little bit more thought. Okay, so there's one other thing I want to go through today. And that's this idea that if a family of lines or a family of points makes up a line, if a line is made of an infinite number of points that are all connected in the same way, well, if a point is on a line, or a point is on a line rather, if and only if its coordinates satisfy the equation of the line. So that means I can take the coordinates of the point, I can put them into the equation, and it works. So let's look at this question. Determine whether 2, 5 and negative 1, negative 5 lie on the equation y equals 4x minus 3. So we're going to take this separately. So let's start with 2, 5. We're going to determine if that point is on the line. So the equation of the line that we were given is y equals 4x minus 3. So what you're going to do is you're going to take the values from your coordinates, right? That's your x coordinate. That's your y coordinate. Put those values into the equation and see if both sides end up being the same. So the y value that we have is 5 equals 4, which was part of the original equation. Multiply 4 by 2 minus 3. So now we just do order of operations to solve this out. 5 equals 4 times 2 gives me 8 minus 3. 5 equals 5. That is true. So that worked out to be correct. That's the same on both sides. So that final equation is true. So 2, 5 is on the line y equals 4x minus 3 because its coordinates satisfy the equation. It works. So let's look at negative 1, negative 5. So again, start with your equation, y equals 4x minus 3. We're seeing if this point is on that line. This is my x, this is my y, so I'm going to plug those in. So we've got negative 5 equals 4, replace x with negative 1, minus, let's just start again. I want it to be color-coded. So 4, negative 1 is what we replace x with, minus 3. So let's see if this works. So negative 5 equals 4 times negative 1, negative 4, minus 3. Negative 5 equals negative 7. Well, that's not true. So if what you find out turns out to not be true, then the answer is negative 1, negative 5. This point is not on the line with the equation y equals 4x minus 3. So plug the coordinates into the equation. If it works, the point is on the line. Plug the coordinates into the equation. If it doesn't work, then that point is not on that line. And that's how you determine if that point is part of that line's family. Okay, so we've talked about the equation of a line being the description, the relationship between all of the x and y coordinates, how they're related to each other. We talked about how to figure out what the equation of the line is if you're given a table of values. If you're given some of the points that are on that line, can you piece together what the equation is? So we did 2 of those. And then we talked about how do you figure out if a particular point is actually on the line. And you do that just by plugging it in and seeing if it works out to be true. And that's it. Thank you so much.